According to the National Electrical Code, it is not code compliant to wire two individual branch circuits to a two-pole switch. This is because of a safety hazard. If a fault occurs on one circuit, it could overload the other circuit, creating a fire hazard. Also, dividing the load between two circuits can cause voltage drop, leading to dim lights or malfunctioning appliances. The manufacturer's suggestion to wire two one-pole 20 amp GFCI circuit breakers to a two-pole switch is also not code compliant. This configuration provides no additional protection and can lead to the same issues as wiring two individual branch circuits. It is important to follow electrical codes to ensure safety and prevent electrical hazards. The recommended solution is to use a single branch circuit protected by a 20 amp GFCI circuit breaker. Now let's delve into some more detail about branch circuits, GFCI protection, and applicable code requirements. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Overcurrent protection is typically provided by a circuit breaker or fuse. There are several types of branch circuits, each with different allowable ampacities. These include 15 amp, 20 amp, 30 amp, and 50 amp circuits. The ampacity of the circuit dictates the type of outlets and appliances that can be connected to it. For example, a 15 amp circuit typically serves lighting and general use receptacles, while a 20 amp circuit can handle higher loads such as kitchen appliances. A 30 or 50 amp circuit is usually reserved for dedicated appliances like electric ranges or clothes dryers. Ground fault circuit interrupters, or GFCIs, are essential safety devices designed to protect people from electrical shock. They work by monitoring the current flowing in the circuit. If the current returning differs from the current going out by a small amount, typically 5 mA, the GFCI will trip, quickly cutting off power to the circuit. This difference in current indicates that some of the current is leaking to ground, potentially through a person. GFCIs are required in areas where electrical equipment may come into contact with water, such as bathrooms, kitchens, garages, and outdoor locations. A National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation and maintenance. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is often mandated by local and state regulations. Let's consider some specific NEC articles relevant to this situation. NEC Article 210.8 covers GFCI protection for personnel. It specifies the locations where GFCI protection is required. For example, 210.8. A5 generally requires GFCI protection for 125 volt through 250 volt receptacles supplied by single-phase circuits rated 150 volt or less to ground installed in bathrooms. Similarly, 210.8. 8.9 requires GFCI protection for all 125 volt through 250 volt receptacles supplied by single-phase circuits rated 150 volts or less to ground installed in kitchens. NEC Article 210.21 covers the use of branch circuit overcurrent devices. It specifies the maximum load that can be connected to a branch circuit based on the ampacity of the overcurrent device. For example, a 20 amp circuit breaker is intended to protect the circuit conductors from overcurrent and prevent overheating. NEC Article 210.23 covers permissible loads on branch circuits. It details the types of loads that can be connected to different ampacity branch circuits. For example, a 20 amp branch circuit can supply one or more receptacles and lighting outlets. However, the total load connected to the circuit must not exceed the rating of the circuit. NEC Article 210.24 provides a summary of branch circuit requirements. It includes information on the minimum size conductors, overcurrent protection, and number of outlets allowed on different ampacity branch circuits. In the specific case of the LED pool lights, the recommendation to use a single 20 amp GFCI protected circuit is based on several factors. Firstly, each 120-volt 50-watt LED light draws approximately 0.42 amps. The calculation is 50 watts divided by 120 volts equals 0.4166 amps. Since there are two lights, the total current draw is approximately 0.84 amps. A 20 amp circuit can easily handle this load, as it is well below the 80% continuous load limit. The NEC generally limits continuous loads on a circuit to 80% of the overcurrent device rating. This is to prevent overheating of the circuit conductors and overcurrent device. For a 20 amp circuit, the maximum continuous load is 16 amps. The calculation is 20 amps multiplied by 0.80 equals 16 amps. Secondly, using a single circuit simplifies the wiring and reduces the risk of ground faults causing nuisance tripping. When two separate circuits are used, even small differences in ground potential can cause current to flow between the circuits, leading to GFCI tripping. Thirdly, it ensures that both lights are protected by a single GFCI device. This provides a consistent level of safety and reduces the risk of one light being unprotected in the event of a ground fault. The suggestion from the manufacturer to use two 1-pole 20 amp GFCI circuit breakers connected to a 2-pole switch is not code compliant for several reasons. Firstly, it does not provide any additional protection compared to using a single 20 amp GFCI breaker. Secondly, it can create a false sense of security, as it might appear that the two circuits are somehow isolated from each other. Thirdly, it violates the NEC requirements for proper circuit design and overcurrent protection. The 2-pole switch would simply turn both circuits on and off simultaneously, but it would not provide any coordination or protection between the circuits. In the event of a fault on one circuit, the other circuit could still be overloaded, creating a fire hazard. To properly install the LED pool lights, the following steps should be taken. Firstly, ensure that the circuit conductors are properly sized for a 20 amp circuit. This typically requires using number 12 American wire gauge or AUG copper conductors. Number 12 AWG copper wire is rated for 20 amps in most common wiring methods. Secondly, install a 20 amp GFCI circuit breaker in the electrical panel. The GFCI breaker should be properly labeled and connected to the circuit conductors. Thirdly, run the circuit conductors to a junction box near the pool lights. The junction box should be suitable for wet locations and should be properly grounded. Fourthly, connect the LED pool lights to the circuit conductors in the junction box. Make sure to follow the manufacturer's instructions for proper wiring and grounding. Fifthly, test the GFCI protection to ensure that it is working properly. This can be done by pressing the test button on the GFCI breaker. The breaker should trip, cutting off power to the circuit. Finally, verify that the lights are operating correctly and that there are no signs of overheating or other problems. In summary, it is essential to follow the National Electrical Code and manufacturer's instructions when installing electrical equipment. Using a single, dedicated 20 amp GFCI protected circuit for the LED pool lights is the safest and most code-compliant solution. Avoid using multiple branch circuits connected to a 2-pole switch, as this can create safety hazards and violate NEC requirements. By following these guidelines, you can ensure a safe and reliable electrical installation for your pool lights. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician has the knowledge, skills, and experience to safely and properly install electrical equipment. They can also ensure that the installation complies with all applicable codes and regulations. Now, let's consider some additional factors that may influence the design and installation of electrical systems near swimming pools. One important consideration is equipotential bonding. Equipotential bonding is the process of connecting all metallic parts near the pool, such as the pool reinforcing steel, metal piping, and electrical equipment, to a common bonding grid. This helps to minimize voltage gradients in the area and reduce the risk of electric shock. The NEC requires equipotential bonding in the vicinity of swimming pools to ensure that all metallic parts are at the same electrical potential. Another important consideration is the location of electrical equipment. The NEC specifies minimum distances that electrical equipment must be located from the pool. For example, receptacles and switches must be located at least 10 feet from the inside walls of the pool. This is to prevent people from reaching electrical equipment while they are in the pool. Additionally, underwater lighting must be specifically designed and approved for use in swimming pools. These lights are typically low voltage and are installed in a niche that is bonded to the pool's equipotential bonding system. The use of extension cords near swimming pools is generally discouraged. Extension cords can be easily damaged or become wet, creating a shock hazard. If an extension cord is necessary, it should be a heavy-duty cord that is rated for outdoor use and is protected by a GFCI device. Furthermore, it is important to regularly inspect electrical equipment near the pool for any signs of damage or deterioration. This includes checking for cracked or broken receptacles, frayed wiring, and corroded connections. Any damaged equipment should be repaired or replaced immediately to prevent electrical hazards. If you are planning to install a new swimming pool or upgrade the electrical system around an existing pool, it is essential to consult with a qualified electrician and obtain all necessary permits. The electrician can help you design a safe and code-compliant electrical system that meets your specific needs. They can also ensure that the installation is properly inspected and approved by the local electrical inspector. In addition to the NEC requirements, there may be local codes and regulations that apply to swimming pool electrical systems. It is important to be aware of these local requirements and to comply with them. The local electrical inspector can provide information on local codes and regulations. Electrical safety is paramount when it comes to swimming pools. By following the NEC requirements, consulting with a qualified electrician, and regularly inspecting electrical equipment, you can help to ensure a safe and enjoyable swimming pool experience. Remember that electricity and water can be a dangerous combination, and it is always best to err on the side of caution. If you have any doubts or concerns about the electrical system around your swimming pool, consult with a qualified electrician.